Hello wonderful person, this is Anton, and in today's video we're going to be talking about the world of the Game of Thrones and a potential explanation for why the climate in the Game of Thrones world is so unusual and so different. Anyway, welcome to What the Math. So a few years ago, I actually made a video about the Game of Thrones where I tried to use the simulation from the Universe Sandbox Square that's been in here for quite a while actually, and tried to explain why the winter and all of the other seasons in the world of Westeros is so unusual. The simulation is actually right here under fiction. There's a Lens of Ice and Fire simulation that kind of tries to explain the climate differences by introducing a second star into the skies. In other words, it basically assumed that there was a binary star system that the Westeros orbited around. I kind of went in a little bit more detail, but today we're going to be talking about a completely different study. As a matter of fact, it's a study that was recently published, and it's a study by no other than Samuel Tarley. It's actually a person on Twitter that has quite an interesting account, and he published this study right here about the terrible weather in Westeros, and you can actually discover this study by yourself. The paper is an actual paper, and it's called The Climate of the World of the Game of Thrones. And I'm just going to give you some of the ideas in here because the person that published the study kind of focused on the idea of applying these unusual climate changes to our own world as well, and even studying other worlds in other exoplanets around our galaxy using very similar principles. Well, let's just kind of summarize this. And what we're gonna do is we're gonna just create a new world here and put a star in the middle, and then just put a beautiful Earth and name it Westeros. And well, let me just kind of jump into the main idea here. And the main idea is that if we were to actually look at the axis of orbit of our planet, but I can actually do this by enabling the axis of rotation right there, you can kind of see that our planet basically wobbles once in a while because its orbit is inclined a little bit. The inclination of Earth right now is about 23.5%, and because of this we get seasons. Now, what we've known for a long time is that this inclination does change with time. As a matter of fact, it changes from about 21 to about 23 degrees. As a matter of fact, this wobble changes by about a degree or even 2 degrees every few thousand years. And this is a natural wobble of our planet. Because of this wobble, once in a while the actual climate changes as well. So one of the explanations for the potential ice ages that our planet has experienced in the last few million years is because of this wobble. But interestingly, our own moon actually stabilizes our wobble a little bit. So if I were to actually add our moon here, and just for the sakes of the simulation, I'm going to place it a little bit closer actually. This object right here, because it orbits around our planet, will now stabilize the wobble. So if we didn't have the moon, our planet would wobble a lot more. Because we have the moon, it wobbles a lot less. It's kind of like a stabilizer that goes around making sure that our planet doesn't really wobble too much. Mars doesn't have this, and because of this, Mars actually changes its inclination quite dramatically in thousands of year period, and its climate obviously changes as well. So if we ever end up colonizing and terraforming Mars, we'll have to deal with the sudden changes in climate every few hundred and thousands of years. Well, how does it relate to Westeros though? Okay, first of all, you need to kind of know a bit of a mythology in there to try to understand where we're going with this. If you read the books, you'll actually find out that there's a story that there might have been actually a second moon around Westeros. And that second moon ended up being destroyed by the star and created the dragons. Now, even though it's mythological, there is a bit of a scientific concept going on here. And the concept is that maybe there were actually two moons around the world of Westeros. And for some unknown reason, one of the moons ended up basically being kind of sort of destroyed. And we're going to do this right now by doing the following. So maybe it exploded for some reason, or collided with something, or, well, we don't really know exactly what happened, but it just disappeared. And two things obviously happened because of this. One of the things is probably there were like quite a lot of collisions that occurred onto the surface of Westeros, or maybe it just kind of flew away and lost its orbit. And oh wow, that was quite a big collision. That would have destroyed quite a lot of things on the surface here. And the other thing that happened, obviously, is that now the planet will have lost its balancer. It no longer has a second moon helping it orbit more carefully. And so because of this, Westeros starts to wobble more and more. And we can kind of try to simulate this by just editing, I guess. So now Westeros will start wobbling back and forth a lot more. And this wobble will probably occur every few hundred years. And if you read the books, you know that the climate change in Westeros, or I guess the sudden winter that lasts for a long time, is sort of something that happens very unpredictably, but it lasts for anything from several dozen to possibly even 100 years. And so the new winter that came to Westeros in the books may actually last for a very long time. Now, obviously, the books use magic to explain it, but we're going to use science. And if you actually read the paper even further, first of all, the person by the name of Samuel Tarley explains how we might be actually missing a big continent that is located somewhere in the south. And he even kind of compares some of the cities to our own planet Earth, very, very accurately, as a matter of fact. And he uses the climate analysis to try to predict where each of the cities would be located. So he places the city of Karth, which is right here, on the equator because of the climate that we experience in Karth, and the other cities are a little bit farther north. So this is the equator. It probably means that there's another continent we haven't discovered in the south, or maybe there's just water there, we don't really know. But on the other hand, this is where you get the divider, the planetary divider. So basically this is the equator, there's a whole new section right here we don't know about, and we basically only deal with the northern hemisphere here. And what's interesting, this person even goes into a lot of detail in trying to study things like the winds and the various climatic patterns around the hypothetical planet by comparing it to what happens in real life as well. So this is a pretty interesting paper to read if you actually are into reading unusual scientific papers. But I guess the main idea is right here. So he demonstrates how the climate might change dependent on the tilt. So whenever there's a large tilt, in other words, whenever the planet is tilted more, so it's no longer protected by the second moon, so it tilts a little bit more, you get very, very, very large variation in seasons, and that's when you would kind of expect this winter to actually come. Whenever the tilt is much smaller, you get weaker seasons, and the winter kind of stays more or less in the north. The other parts of the planet are more or less mild. And he kind of goes into the story a little bit, even predicting potential areas where the White Walkers might end up spending their time when the planet is like this, and even kind of analyzes some of the potential strategies for attacking the White Walkers. But that's another story. That's something that I'm not going to discuss here. We're only dealing with science. And the science here is actually something that you can totally apply to Earth studies and exoplanetary studies. So basically, the fact that the tilt changes affects the climate changes is something we've known for a long time, but it's really the moon that's important. The fact that we have such a large moon around our own planet Earth, and actually let me just remove some of the other fragments so you can see it better, means that our planet is actually a lot better off in being climatically protected from sudden changes by our own moon. So this kind of applies to exoplanets here. If we want to find a world that we can live on for a very long time, a world where we can actually not worry about sudden climatic changes, we have to actually look for relatively massive moons orbiting around that world. Without a moon, the tilt and the wobble will be too extreme, and the climate changes, especially if we terraform the world, will be too extreme as well. But that's, I guess, a potential explanation here. Although there is a bit of a concern with this explanation. It actually does come from the books as well and from the paper. Okay, so in the books we have a kind of equivalent to the polar star. A star that always points at the north that you can always use to guide yourself. And we know that our own polar star, or also known as a pole star, has actually changed positions in the skies because of the 1,000-year-long tilt change. So the North Star was not in the same region a few thousand years ago. In the books, however, there is a similar star that we obviously don't have here, but let's just assume it's this right there, known as the blue star in a dragon's eye. And it has been used in navigation in the Game of Thrones world. But if the world of Westeros tilts a lot, it would actually change its position all the time. So there's a bit of a discontinuity here with the actual tilt theory. So maybe, just maybe, it's not a very robust explanation for what's happening in the world of Westeros. So that one star might actually kind of destroy that theory by itself. But nevertheless, that paper actually does make a few more really interesting arguments. One of them is actually in regards to the climate change due to sudden increase in fires and dragon activity. So here, the sudden increase in carbon dioxide emissions, which we're gonna simulate by adding like a big number here, would actually suddenly increase the global temperatures as well. And what's interesting is that it totally applies to the real world. So because we see so much war and fire going on in the Game of Thrones, this probably would result in the sudden increase in temperature like you see right here. And that also would result in the melting of the north caps, while at the same time increasing the water levels and possibly flooding certain areas, including the King's Landing. And this is something that the paper mentions and kind of made me smile a little bit because I never thought about it that way. And this is something that could actually happen within the period of a few decades, actually. And so the fact that this paper goes into so much detail to try to predict the climate changes and even talks about the increase in water levels and a lot of other things that are concerning us today here on Earth makes this a quite an interesting read. This is actually what Earth would look like if the water level did increase quite dramatically. Now, all in all, I'm actually not obviously taking many of the things in the paper seriously, but it does create a really cool idea of studying exoplanets by using these hypothetical scenarios, even from like science fiction books, to try to study other planets, exoplanets in this case, and try to discover very, very important factors and elements that would determine whether the exoplanet might potentially be habitable for human beings. In that sense, this is actually one of the better papers I've read so far because it does go into a lot of detail and presents quite a lot of really good arguments. But in every other respect, it's just fan fiction in some sense. But in any case, I'm actually going to stop this here because I think if you are a big fan of Game of Thrones and if you actually want to learn a little bit more about the science behind the books, you might want to go and read the paper by yourself. The link for it is in the description below. And I actually I'm going to go ahead and follow this person on Twitter because maybe, just maybe, they will end up posting something else really cool, something interesting, something that relates to the books and to the climate change on Earth. Check out the paper in the link in the description below. Thank you so much for watching. Subscribe if you still haven't. Share this video with someone who enjoys watching space videos and wants to learn through video games and also, in this case, books and fiction and very interesting ideas. And I'll see you tomorrow. Come back tomorrow to learn something else. Space out. And as always, bye-bye.